Hello, Mr. Gray. You early?
Yeah, I know. I should give us your credit, people.
Yes, sir. Just make sure your camera's on the whole time, and remember to start opening up your screens like mine, so you can get ready to turn in some of this work, or get ready to type up with us. We can do the norms, but you're gonna
Yeah,
get 10 more minutes, so people are late. So you got a lot
I'm
of time to set up.
boom. I got two devices, so easy.
Okay. Oh, okay. All right. You do your thing, Playboy. Okay, so this is the timer for 10 minutes, and then we're gonna start. So set your screens up, Gray, and then there's just 10 minutes grace period for people to get in the classroom, and then afterwards they're considered late. Be setting your screens up and getting ready. Make sure you're logged into Edsby and also your Gmail account so you can set up your Google Doc for today's assignment.
And the last class I was in, I was the only one there, literally.
Well, you know it's a weekend, so people are having a hard time logging in.
Right.
I'm pretty sure Tuesday people are going to be trying to get in here.
Mm, yeah, they online knows I need these credits. They know not to play with me.
I understand. I understand. Hello, Mr. Perry. Please make sure cameras are on the entire time of class. Hello, Claudia. Please make sure your camera stays on the entire time for class. We have 8 minutes before we start our class. This is time for you to set up your Google Doc, log into Etsy, and your Gmail account so you follow along what I'm doing. I broke my camera. Okay, I will let Mr. Irvin know that so he can call to your parents and find out what's broken and try to get you going. CPS requirement. She said, "Yeah, I know." CPS requirement is you guys got to be on the screen to make sure you're there because we don't know if it's you with your camera broken. Perry left. Okay. When the clock hits 2 minutes, I'm gonna do attendance. Hopefully, he comes back. Welcome back to class, Mr. Perry. Again, all students, if you have the ability, please turn your camera on. I understand Claudia's camera's broke, but everyone else should have that camera on. If you don't have your camera on or your microphone and not participate, be expecting me to reach out to Mr. Irvin, who will in turn reach out to, I want to say your parent, to try to get you back on track. Okay, Kennard, Autumn, you're here. Welcome to class. Ms. Kennard, welcome to class. We have 6 more minutes before we start. You might want to set up your screen so you can follow along with everything I'm doing for today's assignment. Okay, we got other students coming in the room. Courtney, welcome to class. Mr. Martin, welcome to class. We have 6 minutes before we start. I want to set your screens up, set up your title of your document, header, as well as the title. And we'll talk about what goes into the document in 5 minutes. At the 2-minute clock, I will take attendance again.
Can I present my screen for points?
I'm sorry, Courtney.
I said, can I present my screen for points?
You already got the. Oh, so you know how this goes. Let me stop presenting. Of course, sir. Go right ahead. So Courtney's talking about the fact that if you have work done and you present it, you get extra credit. Anyone else during this 5-minute period can present their work for extra credit.
You can see it.
Not yet, sir. We're waiting on you to share it. There you go. There you go. There you go. Sun's coming up. Someone else is coming in class, though. Edward is here. Okay, cool. And before the 5-minute grace period is up, so he's considered present. We're waiting on. There's Mr. Dixon. Okay, this is from yesterday, right? Oh, you already got the assignment set up. Oh, you're talking about yesterday's assignment, Courtney. Okay, that is considered extra credit. All right, so Courtney, just get ready to set up. We have a drawing we have to put in there, and then we got the steps to the problem. So you got your credit, sir. You can stop presenting. All right, so 4 more minutes, everybody, and that is just as simple as that. Courtney set up today's assignment and was ready to present. If you have yesterday's assignment ready to present, you can still get that extra credit. So it goes both ways. Your cameras need to be on the entire time for class. When I check on you and your camera's not on, and I'm calling on you, if you don't respond after 3 prompts, I will have to remove you, and we will have to follow up with you tomorrow. So please leave your cameras on the entire time for class so you do not have any issues with me or the rules therein. 4 minutes. Please set your screens up so it looks like mine's. Let me present again because Courtney was sharing for extra credit. So you should see what I'm doing currently. Let's see here. There's a few people that have not turned on the cameras. Please do this. I do not want you having a hard time today. Okay, Edward, thank you, sir. Who else am I missing? So Claudia says hers is broke. Autumn's got hers going. Mr. Valencia, does your camera work? Ms. Kennard, does your camera work? And Perry, where's your camera? Kennard's camera's on. We had a few students. There's Perry. Again, this is not me. This is CPS requirement to keep your cameras on. So totally sorry. It affects your grade if your camera's off and you're not participating in class. In the meanwhile, while this 2 minutes is going on, I'm gonna do attendance again, and you should be setting your screens up so you could participate along with me in doing it. Thank you, Mr. Martin. I can see you now, or Mr. Valencia, I should say. All right, let's take attendance one more time. So far, we do not have Miss Archie present. Do not. Mr. Bergardo is absent. Miss Bailey is absent. Claudia is present. Angelina Bravo is absent. Michael Brown's absent. Brian Bustamante is absent. Christopher Clark is absent. David Curry absent. Jamar Davis absent. Shamar Davis absent. Courtney Dixon is present. Edward is present. Chris Flores not present. Jontez Goss not present. Mr. Gray is present. Autumn Hall is present. Paris Hall is not present. Miss Kennard is present. Aaliyah Mims not present. Mr. Perry is present. Hector Sanchez is not present. Royale Smith is not present. Jalen Stuckey is not present. India Tyler is not present. Mr. Valencia is present. Mark Weber is not present. And Davion Williams is not present. All right, so 1 minute, we're going to go through our norms, and then we're going to talk about today's problem. Please set your screens up so you will be able to follow along in class with everything that I'm giving you for notes to handle today's problem. So make sure you have two screens the way I'm viewing it for you guys, and be ready to type up everything. All right, so real quickly, we're going to go through the norms for today. That was the buzzer for attendance. Everyone else after that buzzer is considered late. Wait a minute, who is this? Somebody just came in at the buzzer. Who is coming into the room? Let's see here. We have, oh, Miss Archie made it. She's present. Cool. I can go back and make her present. She just made it at the buzzer before you be considered late. Okay, so Miss Archie is here. All right, I think I got everybody. Okay, so remember, all cameras have to be on for the entire period of class. It makes sure that, or staff will check and see if you are in the classroom. So if I'm asking you, please turn on your cameras because I can't see your camera. It's not on, and I don't want to reverse your marking for present to absent in the attendance category, okay? So work on getting that camera on because I can see all screens at the moment. Now, we're going to go through our norms next because that's the Camelot model and it's our culture. Let me change screens for you guys. I'm presenting. Okay, good. So let's minimize this and open this up. And we'll go down the list, and we're going to start with our basic norms. And this is a check-in, but it also gives you points. So when I call on you, please respond by just reading the number I tell you to read. And then also look at the fact that, let's see here, this goes towards your attendance score. So let's go down the list. Let me see, get a list going. There we go. So first in the list is Miss Autumn Hall. Can you read number 1, please? Miss Hall, are you there?
No one has the right to hurt another person.
Thank you, ma'am. All right, next in the list is Claudia. You don't have a camera, but your microphone should work, right? So can you read number 2?
Education in the classroom are sacred.
Thank you, Miss Claudia. Courtney, can you read number 3?
We will never behave in a way that will discredit ourselves, our school, or our family.
Thank you. Edward, can you read number 4? Thanks for the camera, Miss Archie. Edward, are you there? Oh, there you go.
At Excel Academy of Software, students are always a lady or gentleman.
Thank you, sir. Mr. Gray, can you read number 5?
We take pride in the Excel Academy of Software.
Thank you, sir. Next up is Miss Archie. Can you read number 1?
We respect the opinions of others.
Thank you very much. Next, we have, let's see here. I'm trying to get my mouse to come over here. There we go. Mr. Valencia, you're on here twice. You must be on your phone and laptop. Can you read number 1, please, from the academic norms?
Number 1.
Yes, number 1, sir.
Respect the opinions of others.
Thank you, sir. Miss Kennard, can you read number 2? Miss Kennard, are you there?
That would be respect the culture of the classroom.
Yes, it is. Thank you. Mr. Perry, can you read number 3? Courtney, we can hear that. Miss Kennard, can you read number 3? Is she there?
Me?
Yes, you. Yeah. She said me.
We are attentive and participate.
Thank you. Thank you. Thank you. And Mr. Perry, can you read number 4? Mr. Sherrod Perry, are you there?
Man.
Okay.
Well, no, we have high expectations of ourselves, our peers, and our teachers. We are here to focus on preparing ourselves for post-secondary endeavors.
Thank you, Mr. Dixon. I'll try and give everybody a chance to get points. Courtney, like, hurry up. All right, so let's keep going, right? So let's take a look at this. You're going to be logged into ESB, and I'm going to put in the chat the part that I need someone to read. So let me put it in here. And then you just type me in the chat, or if you're like Courtney, you're just going to go ahead and get out the way so we can get things done. So type me, and if nobody takes, you want to do it, Courtney?
Yeah.
Go ahead, Courtney.
Hello, all future electrical engineers. Synchronous problems need to be completed and ready to present tomorrow in class. Asynchronous problems have to be completed as homework and will be checked tomorrow in class as well.
All right, Mr. Dixon just got 10 points. The next part I need read out loud is, of course, the notes on things you need to remember about this assignment. So let me put in the chat. I'm going to wait a second. Courtney already typed me, though. Courtney's just ready to get this day over with. So who would like to read this one? If not, I'm going to call on Courtney again. But again, he's getting points to do this, so he's not wasting his breath. No one? Oh, Courtney already said me. Go ahead, Courtney. Courtney ain't waiting.
Please remember to get maximum credit. All calculations and steps for the final answer to the problems need to be uploaded to ESB via the same format that we have been using since the start of the quarter.
Thank you, sir. All right. So one more opportunity for points, and we're jumping into the problem now, is problem 1S, which means synchronous. And this is the one we're going to do in class. I'm going to put this in the chat, and I'm going to need someone to read that problem off. So you can type me or someone can read it so we can get started.
To pass,
And this is where, all right, speak.
to pass a slow-moving truck, a driver has to accelerate his fancy 1.3 to the 10th.
Times 10.
Oh yeah, times 10 to the third kilogram. Car from 13.4 meters per second, 30 miles per hour to 17.9 meters per second, 40 miles per hour. In 3 seconds, what is the minimum power required to do this?
All right, thank you. So Courtney took all those points. All right, so he typed me too. Thank you, sir. So what we want to do is what I put in the chat, that last thing, the actual problem, we put it in our Google Doc. So in order to do that, we're going to actually open up a new Google Doc. Make sure you're logged into your Gmail account. And mine's is Camelot, but you might have one that you logged in for Google Meet. So now that you're logged in into your account, go to Documents. And once you're in Documents, you're going to click on or double click on blank for creating a new document. Okay. So the first thing you want to do is make sure you name your document. And we name our document what? Well, it's due now. And then, oh, Autumn left. I hope she comes back. So the due now is what you type there. Let's type that due now. And today's date, which is the 21st September 2020. And then we type our header, which is your name. And again, the date. That'll be 21st 9/20. And the period that we're in is 5th, the very last period of the day. The class is robotics, but the technical name is Intro to Engineering. That's what you type. That is your header. Title. The title is in SB. And I want to see who can get at least 10 points for telling me what today's title would be. So if you're not sure what that is, you just look in EDSB and look at the title. So who can tell?
Passing fancy power.
Who said that, Courtney?
Edward.
Oh, that was Edward. Okay. I'm trying to go back to screen. Okay. So Edward gets those points. And he's right. It's called Passing Fancy Power. I don't know if anybody heard him. So let's type that in for our title of the document. Passing Fancy. And in brackets, you put power, because that's what we're studying today. Okay?
They smoking squares and shit.
Whoa, watch your mouth, man.
Whoa.
Hey, who's that, Edward?
Oh, my
Yeah,
phone.
mute yourself, man. Talking about smoking squares and stuff. All right, calm down. All right, so let's keep going, y'all. Now, we're going to center our title right here, and that's centering it. And then we'll come down, and we need to put the problem in here. The problem is found in the chat and also in EDSB, and it's what Courtney read out loud to us. So I'm going to copy this, what Courtney just read, into the chat. Okay, and I'm going to line it up for you. Okay, now I'm going to talk about what you got to do in terms of getting 25 extra points today, and that's called the word of the day and also the term of the day. And the term of the day is specific to the class. So let me put it in the chat what today's term is.
Mr. Tyler.
Yes. Courtney? He said Mr. Tyler and then disappeared. Courtney, you had a question?
I said I'm finna go to the bathroom.
All right, go to the bathroom. Just come back, sir. So today's topic word of the day is really this list that we go through to get you guys prepared for SAT training. And today's word is ambiguous. So I put this in here. Right after your title, you might want to put that word and that definition in your Google Doc. All right. Now you need one more term to actually get credit, the full 25 points extra credit. And that term is wattage. Okay, so I'm going to take that, and I'm going to, if in the chat someone puts it, they will get an additional 5 points. But what does wattage mean? So you will need a definition of ambiguous, which is an adjective for unclear or vague in meaning. And then you also need to get the 25 points, the definition of wattage. Now, if someone puts in the chat what wattage means, they get 5 points. But to get the 25 points on your assessment or assignment for today, you need both words and their definitions in your document when you turn it in. All right, so take a moment and let's see who takes those points. But let's get back to our assignment, right? So I'm gonna come here. We have our question. You guys have a synchronous problem that we're going to do in class right now, and you have an asynchronous problem that you're going to do pretty much when you have homework time, right? So you guys turn in both problems tonight by 8 p.m. And the problem, Edward took it, I think. Hold on. Edward said, wattage, a measure of electrical power expressed in watts. You get the extra 5 points, sir, but don't forget to put that definition you gave us for both terms in your Google Doc somewhere. All right, I have to see that. So when I go back and want to look and see if you get points for that, it's in your Google document already. So just don't forget. One moment. Sorry about that. I had a teacher call. All right. So now the next thing we want to do is look at the problem. And even before that, let's not forget that there's an asynchronous problem or homework problem that you're responsible for. So come to Edsby, come down here, and I'll put it in the chat too, but you don't need to read it. But it is our homework problem that you need to include in this document. And you have to finish it as well as the synchronous problem by 8 p.m. So make sure you take that and put that into your Google Doc. And I put it in the chat for you in case you couldn't find it in Edsby. That here. And that's a problem you have to do along with this problem that I'm going to do with you tonight. Okay, so what are we working with? Well, we need to understand some equations. And before we can understand the equations that we're going to work on, we need to first create an image that represents what the problem is talking about. So in order to do that, you first click on Insert, right? And then in Insert, come down to Drawing. Once in Drawing, you come over to New, and it'll give you a drawing page where you can start creating an image to go in your document. So what does that look like? Well, we will start with basically a highway because we have a truck and a car situation. So I'm going to start by clicking on line. Make sure you click on line so you can create it.
How we do that? Hey, how we get that little what's it called on that?
What's your call, sir?
That what you're
Drawing.
doing on screen.
Okay, so I'm going to come back. All right,
Yeah.
I'm going to save and continue, come back to this. But all I did was I went to Insert, and I clicked on Drawing, and then afterwards New. So give that a try so we can continue. To get back into the drawing, in case you saved and completed and you want to come back to it, just click on Edit, and you come back to the screen. So all I did at this point is draw a line. And then the next thing I want to do is I want to create one more line because everything in between the lines represents a highway. And we have a truck and we have a car. So I'm going to make this here. And this is our little highway. So let me type basically highway. Okay. So this is the situation we're dealing with. Next, we're going to make some shapes to represent a truck, a car in the beginning, and a car in the end. So I'm going to go to shapes here. Click on shapes. And I have all sorts of shapes I can click on. So for the truck, I'm going to use pretty much this box. And all you do is once you click what you want, you just make a space by clicking and dragging, and then you have a space or a shape for the car itself. I'm going to put this here as the car and shrink it a little bit because I want the truck image to be bigger. So I'm going to go back to shape again. And you can choose your own shapes as long as you know what they are and you can represent them. And I'm going to use this box as my truck. Okay, so I'll move that over. We're going to name these and put some speeds on those because that's what the problem is talking about. Now I want to use the same shape. So I'm going to click on the shape for the car because I need two forms of the car. One is the beginning car. The other is the ending car. So I'm going to hold Control and press C, and then hold Control and press V. And now I have one more car that will show what happens when the car changes speed and is in front of the truck. So let's label these. Hit text box, and in here I'm going to put car. right? And I'm also going to call it car initial. And it starts here with this representation. It's in the back of the truck. So let's move that up. Then we'll have something called car final. So I'm going to take this. Make sure I take only that and copy and paste it. And this is our final position of car in front of the truck as the problem talks about. So I'm going to change this from initial to final. And what happens is that stays there. And then move it down some. There we go. So you can see it. And then in the middle, we call this what? The truck. So truck. And the goal of this car and the problem is to eventually, once it accelerates, surpass the truck in the highway. So we're not done because now we got to talk about the speeds of the car in the beginning and the speed of the car in the end. Well, if we look at our chat, it talks about the problem itself. This is a 1S, or the first synchronous problem. So the car starts off with 13.4 as a speed or velocity, 13.4 meters per second. So make a text box so we can label that, and we'll say velocity initial, or VI, is equal to 13.4, and it's meters / seconds. If it doesn't fit in that little text box, you just stretch it out some and allow you to let it be seen better that way. All right, so that's fine. But now we got to talk about the final speed of the car. I'm just going to copy and paste that text box and come over here. VF, or the final speed, final velocity, is, let me put F, not 13.4, but if you look at the problem, it's 17.9. 17.9. All right, and this is for the car. Now, all this is happening, we're not concerned about the truck because the truck is moving at a constant speed, but we are concerned with what happens between the initial speed and the final speed. Okay, so I think I have everything you need, and then I'm gonna save this so the image goes back into my document that I created. So save and continue. And so far, this is what's happening in your problem. And you need to have this in your problem so you can get full credit, because you will have 15 points taken off. Click on Word wrap text, and this allows you to maneuver the image around all sorts of text. So I'm just coming to the second problem of the day and moving it down because we got a lot of work to do on it. All right, now I'm gonna slow down and give you a moment to recreate this image, which represents our problem. Okay, so you can resize it by grabbing the edges of it once you click on it. And you should have some type of image like I have in your document when you're turning it in.
What if it don't look like yours, but it kind of looks like that?
Well, as long as you have what VI is, where car initial and car final is, you can use different shapes, right?
Like,
You want to make both cars the same shape. Well, oh, I see what you're doing. Okay, so I would need to see your screen better, but it looks like it will work. So once car initial, come over. I'm looking at his camera, and you got to put car final underneath that other one, Mr.
Right.
Yep. And then that should work. But don't forget about the speeds I put in here, like VI and VF. You need those in highway because it shows what your problem is about. Okay, so I'm gonna type some more notes and I'm gonna go over it again. But I want you to have a moment to at least create this image. So you get 2 minutes to do it, and then I'm gonna move on to the next steps. I'll be typing them, and if you're done with this image, you can type them along with me. But make sure you got this image in there, because if you don't have it, that's off. That's 15 points off. Let's see here. Make sure I'm on the right document. All right, we'll take these over here. So take this small 2 minutes to create your documents. All right, get that out of my way. All right, some notes you need. I'm gonna put them in here for you. So today we're talking about power We're talking about work, and we're also talking about kinetic energy. So let me put this in here for those that finish the image. So you have a head start. And these are some of the notes you need to begin this problem. So basically, you need power, which is equal to work divided by time. Power is measured in joules. I'm sorry, power is measured in wattage. Work is measured in joules, and time is measured in seconds. The next equation we need, of course, is work, which is equal to the force multiplied by the distance. Now, again, work is measured in joules, force is measured in newtons, and distance is measured in meters. So after you get done with your image, you want to hurry up and type up this much. So let me leave this here for a second. How much time do y'all got left that I gave y'all? About 30 seconds. So I'm going to give you about 2 more minutes to type up powers or the notes I have here for you. Let me blow it up some so you can see it better. I'll also try to put the notes inside of the chat for you. So that will help the notes in your actual report.
So on my screen, it's like it done went to the whole other side, and I don't know how to fix it.
What do you mean by the whole other side, sir?
Like I can see the other half of the problem. Like I can see only one side of it.
Okay, I'm gonna stop sharing. Can you share your screen and maybe I can help you with it? Everyone else start getting all that typed up and your image ready to go. Okay, so Edward, you can share your screen and I can see if I can help you with that.
You said I can't.
Yeah, I'm saying I'm asking you
share my
to.
screen?
Okay, yeah, you got it going. Now, what are you talking? Oh, okay, so you're trying to correct your text box.
No, I'm trying to.
So you got it, but you just got to resize that box. So the way you resize the box is you see the little box. No, that's rotating. You don't want to do that. You can hit undo and put it back. So you see where it has the arrow for undo? It's like an arrow going backwards up the top. So come over. Nope, come over.
This right
come
here?
over to the left. Come all the way to the left. It's one that says undo. Yeah. Okay. Now click it again. There you go. Now resize it. Grab the blue boxes around. So you got to resize it from the sides. Yeah, you did it from the bottom, top. Now resize it from the side. So there you go. Now drag that over. That way it'll fit on your screen the way you want. Okay.
Now how I make it where you can see the whole thing and not just this side.
You got to scroll back over. There you go.
On my phone.
Okay. All right, and then you hit save, continue, and it should go straight in your document, sir.
Mm-hmm.
All right, awesome. So let me share again. This point, we should have all of our notes. I gave you the notes. Let me share again. And you should have all of these notes for for the power, work, and I put it in the chat too. So make sure you type that up. But there's one more equation that we need, and that's kinetic energy. So let's begin. I'm gonna give you the kinetic energy note in the chat for you, and let's see if it works out. Well, let me put it here, and that's going to be this. That's delta KE for kinetic energy, where change in kinetic energy, as you can see, is equivalent to 1/2 times the mass times the velocity, and then you're going to put F and do subscript because it's a lowercase f, and then you're going to do superscript for the power of 2. Okay, so if you're not sure to do that, you would type F here, highlight it, go to format, and then go to subscript. That'll make it drop down so it's mathematically correct. And then for a power of 2 or exponent, you would put 2, highlight it, and put superscript to raise it to a power of 2. So I'm gonna try to put this in the chat, but I don't think it's gonna look the way it looks in the document. but you should be typing up the same way to get the full credit. So let me try to put this in the chat. And you got to make it look like I've done, but remember to find delta, this character here, this little triangle, you need to go to insert. And then when you hit insert, you go to special characters. Within special characters, you're going to make sure you select math and not arrows. So then you can type delta, right, which is that character that you saw, DELTA, and just select the delta function that you see, right? So let me, where did that delta go? Make sure it didn't go to the wrong place. It didn't. Okay, it doesn't even show, so I didn't click on it. But that was how you get the delta function, okay? And I put in the chat what it should look like, but you see where it says,
So we got to put this right under the highway.
yes, you're finishing all these notes under your highway drawing. So you should have all of this so far, right? This part you should be almost done typing up. So I'm gonna put about 2 more minutes on the clock to give you time to type that up. Remember, it has to, like, you see, if you see velocity F, the F is subscript, the power of 2 is superscript. And you got to type it up that way because it's a mathematical document you guys are generating. So take 2 minutes to get that together, and then we're going to jump into the problem with our known and unknown values. All right, we're coming to 40 more seconds before we jump to this problem. I'm going to continue on and just put what we know and what we don't know. I'm getting this from the problem itself. So there's one more line of instructions you need before the known values. I'm going to put this in the chat for you. And then I'm going to show you how it should look in your document. So let me go to chat. So right after the delta kinetic energy, you have this line that you have to include in your notes. Okay, now when you see 2, I want to make sure you see 2. Some of those 2's are raised to the power of 2. And you got to use superscript. 1 second. Let me turn off this timer. Okay. So if you notice, the next line of notes you need is where you have the final velocity or the final kinetic energy, and it's going to be composed of 1/2, which is 1 divided by 2, that's 0.5. Mass is measured in kilograms, and velocity is measured in meters per second, but you know it's squared. So I put it in the chat, but if you look at what's in the chat, this power of 2 is not raised. So you got to highlight the 2 that you have when you take from the notes and go to format and clean it up by making sure it's raised by subscripting. The same thing happens here with this power of 2. It has to be subscript for it to look correctly. And again, this video will be available to you guys to review later on in case you want to get all the notes correct. So just copy it over and clean up those 2 parts. You have this power of 2 here, and this power of 2 here. In the chat, looks like just a regular old 2. So I'm helping you out, but make sure you clean it up so it looks exactly what I have on the screen. Let's give you a minute to type that up. Or you just copy and paste it and clean it up. So to like 1 minute and 30 seconds. Because it's 3:22. And honestly, I'm trying to let you guys go anywhere from 10 to 5 minutes early because we've been sitting here working on this. So make sure you have this part typed up exactly the way I do. Don't copy and paste it from the chat and leave it as is. Clean it up. Make it look exactly given.
Yeah, I forgot how to do that in the little tool. I know it's somewhere up top, but I forgot.
So if you have a 2 that's not a raised 2, you highlight it and go to Format, Text, and Superscript, if that helps. It'll raise it.
Yeah, thank you.
And then when you get done with that, make sure you turn it off. Like come over one when it's already raised to 2 and turn it off because it will make everything else raised to an exponent. So turn it off so you can type normally.
All right.
All right. So we got about 7 more minutes to knock out the rest of this problem. One part of the problem that you guys are responsible for is finding the power, and I will get you there, but you just got to finish it off. But in the second problem, or the asynchronous problem, you do have to do all the steps I did prior. So let's get started on at least figuring out most of the problem, and then the rest will be for you guys to finish off. All right. So we need known and unknown values. Well, if we come here, we notice that we have a mass. Let me stop this timer. We have a mass that corresponds to the mass in our kinetic energy equation. That's delta KE is equal to the mass times the 1/2 the mass times the velocity squared, final velocity squared, minus 1/2 times the mass times the velocity squared initially. All right. So known values, what do we have? Well, for the sake of time, I'm going to give you the values, and you have to type them up or paste them in there. So, because we're running out of time, I got 5 more minutes left. So let me grab this for you. So here are your known values. I'm going to put this in the chat as well. Okay. And this will allow you to catch up to speed. So we're not all the way here late. So let me put it, I put it in the chat, but let me show you how it should look in your document. And this is how. You have a known value, which is the mass of the car, and it's equal to 1.3 times 10 to the 3rd power in kilograms. You also have initial velocity of 13.4 meters per second. I'm getting all of these values from your problem, by the way, you all, so don't be confused. Next is you're given a final velocity of 17.9 meters per second. You have an overall time that all this happened for the acceleration of, this goes in your unknown, right? I mean, your knowns. Let me just bring this down so you can see that by itself. This is what you should have for your known and unknowns. All right. The question is asking for how much power in the end. And that's why it's question mark watts. So make sure it's typed up in this fashion to finish the problem off. All right, just trying to wait a second to make sure you have it. All you gotta do is take it from the chat and put it in your document and make it look as if I have it. Okay. Our next step is looking at what we're gonna do to calculate just the car initially for its kinetic energy. Now we're calculating kinetic energy because kinetic energy, as I said before, is measured in joules. Joules is a form of work, and work allows us to figure out power. So we got to first calculate the kinetic energy in order to figure out how much work we have in order to calculate the power. So what am I doing there? Well, I'm going to put in the chat the next few lines because it's like 3 minutes of class left. The next few lines that you need to calculate the rest of the problem. And then you guys are going to calculate work on your own. That's how you finish the problem off. So strategy, what is our strategy? So I'm gonna put this here in the actual Google document. That's our strategy, right? So I'm gonna put it in the chat, but I'm gonna talk through it so you understand what you're typing. And again, the video will be available, so do not panic. But here's what you're dealing with. You have delta kinetic energy, or change in kinetic energy, which is going to be equal to the equation we talked about earlier. Then you have, Ms. Kennard left. Then you have delta KE with the number values inside. So it's 1.30 times 10 to the third kilograms. I got that from our known values. Multiplied by 17.9 meters per second, because that is our final velocity, VF. Minus, and don't forget that VF is squared, looking at our equation here. See that 2? Next is going to be minus 1/2 times the same mass. You move this out the way. And that's 1.3 times 10 to the third kilograms. Multiply it by 13.4 meters per second, and it's squared. Okay, put a parenthesis there. So all of that's going to be squared. At least the velocity part is. And then the next step shows you that you have to cross some things out. So to cross things out, in case you forgot, use what is called strike through. So a few more steps. Y'all might get out of here 5 minutes early, not 10. But you cross out kilograms and meters per second in each situation because joules pops out for each of these kinetic energies. All right. So if you're not sure how to cross things out, you highlight what you want and you go to text and strike through. All right. Don't just copy and paste from the chat what's there. Make it look exactly as I have it here on your Google Doc. This is just to help you with the notes and get them done sooner. Next, we have 1/2, and this is what happens when the crossed out terms go away. You have this equation here. To calculate it, you simply go to your symbol app and you put in everything that has been, because this is a consolidated. Joules is at the end, and then you just put this into Google, or I'm sorry, symbol app to calculate it correctly. So to do that, I'm going to highlight this portion, copy it, and I'm going to go to symbol app real quick. And you want to use symbol app because when you copy it to Google, it's not going to always put the powers of 2 or 3 in their appropriate place. So we put symbol app in here so you can calculate things such as power in the last steps. And copy and put it here. And that's a nice online calculator you can use for almost everything. Make sure you bookmark symbol app. All right, so the final answer is basically going to be 9,429.91 joules. Okay, and don't forget to make sure you use the same characters that I've used. So that is close to the final answer, because after you do this, and I calculated that putting it in symbol app. So make sure you have the correct answer to that part because you need it for finding power. How do we find power? Okay, well, we know from earlier that power is equal to the work divided by the time. And in order to find the work, we had to find the kinetic energy, which is similar to work. Once we do that, we can put that form of work into this calculation for power. And here's what happens with that step. I'm gonna put it in a chat for you as well, so you can put it in your notes and make sure you have it. So we know once we found the amount of kinetic energy, we can use that for a form of work. And that looks like this. The power, as I said before, is equal to work divided by time. And another way to say that is use the delta KE here that we found from the above steps to find the work overall. So that'll be this 9,429.91 joules divided by 3 seconds, because that was the time we were given in our problem. The final value will cross out joules and seconds and leave only watts. Now, I want to make sure it's clear Did I put it in the chat, that step there for you guys? Let me make sure you have everything. There we go. There's a final step before that, before you find watts. Joules and seconds, they will become watts. So I'm going to cross out basically, oh, I didn't want to do that. Hold on. Cross out using this equation, the joules and the seconds. This is a step that you got to put in your calculations. And what happens is this is gone. And cross that out. And joules is gone. And cross that out. So now, when we do that, what you understand is watts will appear, because when you divide joules by seconds, that's the new dimension you have. I turned it off. There we go. So it's watts. So when it becomes everything else, you're just simply putting this value here, which is joules are gone, right? Because we crossed it out. And the seconds are gone, leaving only watts. So this is the calculation you need for the final answer for power. And I'm going to leave you to calculate that correctly. It is now 3:34. Class ends at 3:40. Again, all of the notes you should have at this point, plus the notes I gave you, should be in your document. Don't forget about the word and term of the day to be included. I showed you that earlier. Make sure somewhere in this document we give the term and the words definition in this document, and you'll get an additional 25 points. So I think that's everything. Don't forget, this problem here uses the same calculations, but you got to think about it because it's a homework problem. And it has to be turned in at the same time you turn in your synchronous problem above to get total credit. Only doing what I've shared with you guys in class with the diagram and everything will get you about anywhere from 50 to 65 points with the diagram. But to get the whole 100 points, you have to attempt this problem using the same techniques I showed you earlier with power. All right. So at this point, it is 3:35. Does anybody have questions for me before I begin to dismiss you all? You need me to scroll up? You need me to explain something? Now's the time. And again, this is all due by 8 p.m. tonight. No questions? All right. Okay, it seemed like Gray left. All right. So if there's no questions, I'll see you guys tomorrow at the same time. Please turn this in. And if you're like Mr. Gray, you have something to present tomorrow, you can get extra credit, meaning you showed that you finished the assignment and you can present the work. So I'll be here until 3:38. If you have questions or you need me to scroll up or scroll down. You said what, Edward?
So you said we got to show you that we what's called the problem.
So you mean no? You don't have to show it to leave. I said you can show it tomorrow for extra credit, meaning if it's all done. But it is due by 8 p.m. tonight. Okay.
All right.
So if you have no questions or anything else,
I already got
go.
everything down.
Okay, we'll just make sure you do that other problem and turn it all in before 8. All right. Well, I'll see y'all later. I see people will leave them. Okay, let's see who's still here. It's 3:37. Miss Archie, who else? Mr. Perry, Courtney. Perry left. Courtney, did you have more questions? Miss Archie, did you have any more questions? Okay, then you're free to go. Please get everything turned in on time, and I'll see you tomorrow. See who else is in here. Mr. Dixon, are you there? Courtney? All right. Get this video ready. I think Courtney stepped away.